Okay, everybody, welcome back to the Assembly Weekly Show. Uh, as you know, we are doing our workshops all online and from home as it happens these days. Today, we're going to switch back to code. Last week, we did a very hardware, embedded systems oriented workshop, but today, we're going hardcore into code and specifically into DevOps. And I'm going to introduce our guest speaker in a little bit. I'll just quickly walk you over it since there might be some people who are coming here for the first time. Here, let's have a look at what the assembly is. And I'm just going to bring that up. So we're a smart lab that's been based out of Infight for the last 5 years. We've done over 250 free workshops. Most of them have been in person, but over the last month, we've switched to online. We've always done a live stream accompanying our live workshops as well, but now we've kind of made it a bit more sophisticated, so it comes out on different channels. It does many different things. We do focus on, like last week's workshop was a hack workshop where we worked with embedded systems, IoT, and hardware. And this week's is very much a code workshop where, which covers a range of topics. We work with APIs, frameworks, apps, and of course, DevOps. We've done maybe one DevOps workshop before where we worked with Docker. Today's is a bit more sophisticated. We're going to be working with both Kubernetes as well as GitLab. So we're going to show you how to go from end to end. So from source straight away to that. So our guest speaker will introduce all these concepts. And of course, he's written a few tutorials on that also. So he'll share that too. We also have data science workshops, which we do from time to time relating to more advanced topics. And all of them are hands-on, and we try to make sure. So our target audience is across the board. We have students, we have professionals, we have entrepreneurs. Of course, Infive is an entrepreneurship hub. So we get a lot of entrepreneurs who are interested, and we're always focused on practical applications. So we try to show you how you can build something by the end of our session. We don't go into depth in the session usually because we have a limited time, but we try to make sure that we cover enough so that you feel like you can walk away with you've built something there. You've all signed up for our forum, I hope. Our forum is where we manage all our RSVPs, and we maintain how we can make sure, all these different things, how we can like allocate resources and check that we have enough space for everyone when we do our live sessions. And of course, it also helps us plan our online sessions too. You can also find a lot of resources on there. We post pictures, we post links, we post GitHub links. There are many things that we do on the forum. It's supposed to be a resource, and we like to use it not just to interact with us, but we hope you'd use it to interact with each other also, so that we can build a nice technical community out of Dubai that is able to, self-sustain when it comes to skills, and we don't have to depend too much on external training systems and all that. We can do things for ourselves. Today's workshop is also going at you're probably watching this live on one of our different systems. We are very active on social media, so you can find us as Make Smart Things on Facebook, Twitter, and Instagram. And we do a lot of YouTube videos. This is live right now on Facebook, Twitter, and YouTube, as well as our website where the YouTube link is embedded. Chats, your best bet to get a response from us is probably YouTube, but we will look at Facebook comments also from time to time. You can find us on LinkedIn. We're not live on LinkedIn yet. I think LinkedIn has a beta video stream, but we haven't been able to activate that yet. But that is in the plans. We are, as we mentioned, we are going out on multiple streams. If you are going to interact with us, please do use these social media handles and hashtag us if you feel like it. We will definitely look forward to seeing your feedback on all the sessions that we are going to be doing. So just coming to today's topic, like I said, we've not done too many DevOps sessions before, but we've seen there's a big request for that. So we've tried to introduce a few new sessions relating to DevOps as well as computer security, things that are more for hardcore developers, because that's the need of the hour. And nowadays, of course, with the situation at hand, security is super important, of course, as well as, containerization will also play a role because software is playing such a big part, and you want to be able to get your software out there fast and make sure that it doesn't have too many issues when it is being deployed. So I'm going to just bring Arsalan on the screen. Arsalan, I think your mic might be off right now. Arsalan, hi, can you see me? Can you hear me?
Yeah,
Hi,
I can
Arsalan.
hear you, but I cannot see you.
No worries.
Yeah, hi
You'll be able
Nikhil,
to
how
see
are
me
you?
later. We are connected via Zoom. So Arsalan is speaking from home. Arsalan, thank you so much for doing this. I know we reached out on the GDG,
My pleasure.
where and I know you're an active user there, and you've told me that you have a long background. I heard from you about working with software in general. I mean, DevOps is
Yeah.
a focus you have right now, but you work with everything, right? Like ranging
Yeah.
web development to app development to many different things. And
Yeah.
but I believe
Thank you.
you are using what you are going to present to us today. It's something that you use for your startup, or sorry, for your company, Fix on Click. Is that right? Like you have created a microservices architecture, and you've used
Hmm.
what you're doing right now in at work as well.
Yeah.
Is that correct?
Yeah. So basically, uh, Kubernetes is, or I would say, the microservices is now the core of all the enterprise applications. So um, I think every other app in the market would be using microservices right now. So it's not only fix and click, anything you name it, especially Netflix, Amazon, Microsoft, everybody is using microservices. So we'll be taking a deep dive into microservices and how we can use it. And thank you very much for giving me this opportunity to,
Oh, well, thank you.
talk about microservices.
It's like
Thank you.
we work with how we are able to share info is through experts like yourself. Before we get into that, it'd be great if you can also say a little bit about your background. Like
Yeah,
obviously you have, I think, 20 years experience. And
yeah.
you've probably seen a lot of changes in the software. As a software developer, you've probably seen a lot of changes come up in the last 20 years.
Yeah, so basically, I started up with software development as a software developer back in 2003 or 2002. And
So that's pre-Facebook
uh,
times.
yeah, so it was mostly in C and C++ and all that. And then I got into technology business once again. And I started up another company. There also, I was involved in integration and technologies related to home automation and home security solutions and all that. Later on, I started up this Fix on Click, which is a tech startup in Dubai, and now I'm here.
Oh, wonderful. And specifically, like DevOps, when did you start realizing that DevOps is a worthwhile investment for your work? Because I know many developers, when they start off, they don't think about these kind of things to organize, and they don't think
Hmm.
about like how can I shorten my deployment cycle? How can I continuously integrate and test everything? They think we'll just do it manually. It's a pain, but we'll do it. Or it's not worth automating. So when did you start
Yeah,
thinking along those lines?
yeah. So basically, I kind of provide software cloud native consistency to different companies where I emphasize on this particular point that when we start a new project, DevOps is the core, or I would say the cloud native architecture is the core right now. So in today's world, if your infrastructure is not well designed, I don't think your application would reach a certain level. So it's not only DevOps, it's a complete network, or I would say cloud native application architecture that you need to design. Your application software development will be completely changed once you start looking at the application from a cloud native point of view. So this is where I think DevOps plays a very important role.
Yeah, absolutely. And we're all seeing the different ways it goes on. So I'm going to leave you with it. I will keep checking
Yeah,
up on questions that are coming up in live chat, and I will pop back in to the to the here to just ask you in between. I'll keep a
yeah,
monitor of like what's going on our chat rooms, just to see, because
yeah,
I'm sure people have a lot of questions about the work you're doing beyond what you're just presenting. I think you'll
yeah.
also
Okay.
share some links. You've done a few
Yeah,
Medium articles. We'll also
Yeah,
add it to our description later, explaining what you're doing, because I believe this is like the second iteration. You've done it with Docker first, Docker Swarm, and working
yeah,
with the cloud interface
Kubernetes
there.
as well. Yeah,
But so we'll share all the links that you have later on, but it'll be good if you can also show
yeah,
it. So I'm going to bring you up on screen right now. You'll be on full screen in a minute, and I'm going to go off there. But yeah, do let me know when you want the presentation up, and then I will switch to the presentation
yeah.
view.
Just put the presentation up, and
Okay.
I will be
Okay.
starting it.
Got it. So I
Thank
will
you, Nikhil.
start up with the presentation. Should be up.
Thank you. Okay, so thank you, Nikhil. Well, my name is Arsalan, and I'm a cloud native architect and a CTO for a startup in Dubai. And these are my links. You can find me here, and I will immediately start towards the agenda of today's presentation. So basically, what we'll be looking at is the containerization of the application, why it's important, what it is, and how we can do it. And then we will dive into the container orchestration, uh, why it's so important, and why we need it. Because if the microservices are there, then I think most of the companies think that okay, our application is microservices based, and that's enough. But there are many more things that we need to do to handle the microservices, and we will look into that in container orchestration part. Then we will look into the CI/CD part, why continuous integration and continuous delivery is important, what different application development frameworks are talking about, and how we can achieve that easily. And then we will look into GitLab, what is GitLab, what it gives us, and what are the different benefits we can take from GitLab in our application development environment. And then we will dive into the demo. So I have designed this presentation for very layman people. Even if you are not a software developer, you will or a core DevOps, you will still be able to grab something out of it. And for those who are already seasoned DevOps, I think you stick to it till the end, because the demo will describe a lot of things for you, and I will try my best to give you something new. So let's get into the containers. So why we need containerization, or what it is? So basically, containerization is, um, first of all, we need to compare what's there in the legacy market, what people were using before containerization. So if you know that AWS, the Amazon Web Services, are there because of the virtualization. So initially, they started up with the concept called virtual machines in their operating systems, and they installed it in their cloud or data centers in all their servers. So all those servers were having many virtual machines, and you hire those virtual machines and put up your load on it. So containerization is basically replacing those virtual machines into further micro operating systems, or you could say processing machines. So what's the difference in the core architecture is that the virtual machines comes up on a hypervisor, or I would say on a hardware, where they need an operating system on the host, and then there is an hypervisor in the hardware that supports those virtual machines, and then you prepare a complete virtual machine with a separate operating system, with your bins, different other files, and all that. And on top of it, you deploy your app. So let's say in this example, in this picture, I'm showing an app 2 and app 3, which is residing on a virtual machine, which is installed on a guest operating system. When it comes to Dockers, so when it comes to containerization, we know the biggest containerization infrastructure is Dockers. There are many others as well, but Dockers is the most famous one. So I will stick to Dockers. So what Docker does is it uses the same operating system, same infrastructure, and it installs a Docker engine on top of it. However, when it comes to the deployment of the Docker containers, it does not require a guest OS. It has a very small fingerprint, and you can deploy hundreds of Dockers on a very small machine as well. So, whereas when you deploy an app on a virtual machine, you require huge resources, you require huge memory, huge CPU, and you might end up deploying only two, three, or four virtual machines on a very nice hardware machine. However, in case of Dockers, you can deploy maybe 50 or 100 apps on a single bare bone, bare metal machine. So let's get into the Docker's application code. So basically, I will deep dive into Docker's uh, architecture by showing you an application which is written in Node. So this is a code that I have written, a very small Node application. So it is doing nothing. It's just taking all the requests from on port 80 and just responding with a hello world message. And on the console, we will be looking at a server listening on port 8080. So I'll be showing you this particular example by running it in my console. Then we need a Docker file to convert this particular application into a container. So that's the only part, that's the core part of Docker. That's a complete anatomy of an application converted from a legacy application into a container. So if you have these two files, an application code may be written in a JS file and a Docker file. That's it. Then you only need a Docker engine to convert this particular application into a complete Docker file, container. So let's start. Let me show you this by just giving you an example over here. Okay. So here I am. If you see, I have just only two files, a Docker file and a server.js. So all I need is convert these two files into a container. And what I can do is I can use a Docker build, and then I can tell it that, okay, this directory, use this directory to build a Docker. And then I can name that Docker to be assembly example. So when I press enter, it will start building my container. Now it has created a container with this name. So let's see if we have it. Docker images. Now we have this term called images. So images in Dockers are the kind of manifest to create multiple containers. So I have a lot of images in my system which I can utilize to deploy containers. So if you see, I have written wrong spelling here, but that's okay. Okay, I'm just changing it. And if you see that I have this Docker built already 11 seconds ago. Now what I can do is I can utilize this Docker by running a container from this particular image. Okay, so Docker run, and then I can tell it that I want to run it on port, let's say 8080, and forward it to port 3000. So port 80 is basically the port that we were looking at here. So if you see, we are listening on port 80. And for that reason, we'll be forwarding all the requests from our local PC to port 80. And then we will name the Docker image, which is assembly example, if I'm not wrong. Okay. So server is listening on port 8080. So let's do it. Let's test it, whether it's running or not. Localhost. It's a demo time. You never know. Okay. Hello world. So that's it. That's all we need to do to containerize. And now, if I want to run another application, all I need to do is I can run another one, and I can say that for use port um 80, 81, forward it to 80, and the same assembly dash exam it will run 8081 is taken. Okay, 8082. Okay, so okay, I will increase. So we have this another container running on port 8082, one container running on port 8080. So all of these applications are running already, and I can run as many as I want. So basically, what is running and what is this Docker all about? So I will just deep dive into this Docker file to let you understand that what exactly is this Docker file and how it is encapsulating the application code into a container. So first, there are only 4 commands that I have written in the Docker file. The first instruction says that prepare a container from Node Alpine, and I have just given a version of that particular server. So basically, Docker file will look into Docker Hub, which is a repository, online repository for Docker registries. So there are many companies. There are many companies like Node, like Microsoft, and all other Red Hat and all other big names. They have kept their own images of their assets or of their software assets into software Docker containers. They containerize it already and they are free to use. So what I'm telling this Docker file is that look on that Docker Hub for a node container or node image with the version 12.16.1 running on a Linux Alpine. So by doing this, it will download that image into my uh, local Docker engine, and that particular container will be containing an Alpine version of Linux. On top of that Linux operating system, there will be a Node version 12.16.1 installed. So I have that image ready in this Docker file when I write from. Then I copy my local directory into the local directory of that container. Then I tell that once that is copied, and if somebody tries to do Docker run, then run this command. This command is basically the node server. So if you see here, when I was showing you my local directory, it was basically, it doesn't terminate. So you have to be very careful with it. When you run, either you can run in daemon or, okay, cd desktop. This is our code, and I have to, okay, now the font is okay, Nikhil? Okay, so if I do this, my file name or application file name is server.js. So I will just move this here, move this here, right next to it. Okay. So what I'm telling Docker is that run this server.js in Node. So that's the third command. And then I'm telling that server that expose your port 80. Why am I'm exposing 80? Because I'm listening on port 80. If I'm listening on another port, I will be exposing the other port. So that's it. By doing this, we have created an image, but that image is created in our local Docker engine repository, which is here. So if you see, that image is created here. And if I want to push it, I can use a Docker push command, and it will push on my repository or my account on Docker Hub repository. So this is where Normally, the term that is used for Docker Hub is registry. So Docker registries are there on cloud with the name of Docker Hub, or even Google has its own Google repositories for Dockers. You can host it there, and GitLab also provides um, these these repositories for you. But here, all of these images are there in my Docker repository, which is in my local machine. Okay, so this is all from the Dockerization or containerization. So I have ran these commands basically in the terminal, and I will be showing you another command, which is docker ps, which shows the running containers. So if you see, I have two containers running from my previous commands, which are 5 minutes and 6 minutes ago. And then I have 18 hours ago one a small container which I was testing. So, anyways, this is how you can see what all is running. So, as I was mentioning, that by Dockerizing or by containerizing the applications, you can run many different applications on a very smaller machine compared to virtual machines. And it's very easy as well to port the codes or to port the images from the Docker Hub or from other repositories. And it's just a small command, and it runs so quickly. Okay, so let's get into the complexities that it brings. So once you start containerization and you develop your application using microservices, you get into a huge complexity because everything is broken down into pieces. For example, an application would definitely require uh, user authentications, payment gateways, accounting, product listing, carts, cart handling, notifications, and push notifications, and I don't know what and what. So when you break down the application into microservices using these separate concerns, what you do is you bring in a lot of complexities. A lot of these applications have to start communicating with each other. And that communication brings in huge complexities because there is a possibility that some microservice or one of your microservice is down or is not healthy or it's not ready yet, and you are sending request to it and thinking that the request will be fulfilled and you will get the response, but you will not get the response because it's not up or because of any reason. And what happens is that you get um, unexpected responses, and you will scratch your head to find out what is down, because you would have to find out in a big microservices cluster like these. So if you see, Netflix has more than 700 microservices, but when they start running it, they run more than 200,000 instances of it. So these 200,000 instances of each microservice, if any one of them is down, how would anyone would know that that is down? So they will have to have a system to monitor all of these microservices which are running on cloud. Same is the case with Amazon. Amazon has even more microservices running to support their Amazon.com and even their backend infrastructure as well. So this is where the orchestration, the container orchestration comes in, and they rescue you with many different features to handle these microservices. So first of all, they give you the configuration and scheduling of containers, which means that just in case if you want your application to handle more load at nights, for example, because your application is something like, let's say, Facebook or Twitter or something of that sort, or social media kind of application. And you know that people, when they go home after the work and sit in their washrooms, they start using it. So this is where you want to scale up your application. That means you want to increase the number of microservices deployment on your cloud. So you can configure that. You can schedule it using this. You can deploy maybe 100,000 more microservices at night and kill them in the morning as well. and all of this will be seamless. Nothing will be touched in a way that it will get broken. And even if some microservice gets down because it's not healthy, or there was an error or something of that sort, the orchestration engines will restart it automatically. So this can be done with the provisioning of deployments. And then at times that you would think that you want to automate the A and B testing. That means you want to deploy a new feature to 10% of your audience, and you want to keep the old features for all of the rest of the people or the users. What you can do is you can automate this by canary deployments. Uh, I'll be taking different acronyms, but you don't get into that. The idea is that you can deploy uh, A and B, or maybe C, D, E, as many different types of deployments for different percentages or regions, or even kind of people. That okay, this guy is coming from, let's say, India. Show him this particular interface, or land him to this microservice. So this is how you can control the A and B testing, and all of this can be automated as well. You can scale for high availability, which I have given you an example. At nights, you can improve the horizontal scaling by doing it automatically, or you can schedule it as well. You can do it on demand as well by running a simple command. You can do load balancing. Since you have 200, since I was giving you an example of Netflix, where it was having 200,000 microservices instances running out of 750 microservices. So that means it has a lot of different instances. For example, 20, 30, or maybe 100 instances of a single image. For example, we can say that a streaming server has more than 500 instances running on cloud, each one of them handling the same traffic. But how would you route the traffic? For that reason, you need load balancer. The load balancer will sit in your cluster and route the traffic coming from different users based on the usage, based on different other rules and criterias that you can define. It will also do routing. For example, a traffic coming uh, from a particular region, and you want to route it to the CDN, the cloud front, or something of that sort, and you want to route it from there. You can do that. And then it also does the service discovery, because the within the cluster nothing can get in until unless you don't expose it using ingress or something of that sort. So for service discovery also, there are certain services that runs in your cluster. Then comes the monitoring and analytics, which is very important part in a Kubernetes cluster or an orchestration cluster, because you would never know how much load is coming on a particular time, and define that okay, scale it until unless you don't get the analytics of it. Then security and control, obviously it's important, and then you can secure your cluster by implementing different security rules and secrets and all that. So yeah. Yeah, okay.
Okay, sorry to interrupt. I'm just going to come in for one question. Varun D from our live chat has asked, and I think you did cover that also. But you have experience with Kubernetes, but how does it compare against Docker? So that is his question, and maybe that might be
Okay.
already covered in what you're going to go on with. But I just wanted to
Yeah.
post that to you.
Okay. So basically, when I started in my agenda, I just mentioned that we will be looking at containerization. So containerization is all about Dockerization, or making the application images, a runnable application images. Whereas Kubernetes is a container orchestration engine. So it helps you orchestrate those containers that you build with Docker. So they go hand in hand. It's not that Docker is separate or Kubernetes is separate. They go hand in hand.
I think that's
If
a
Docker is
mistake.
there, Kubernetes basically will orchestrate it. This is what I explained it here, that we were building this Docker. And then once we build a lot of Dockers and we run them on cloud, we get into complexity. And Kubernetes comes in to handle that complexities.
So yeah, I mean, I think that's a great point, because I know many people, including myself, have that
Yeah.
confusion. They say Docker versus Kubernetes, but you're right. It
Mhm.
is completely separate, and
No.
you have to use hand in hand. And of course, like I
Yeah.
mean, whatever people feel comfortable starting with is what they would go with. But you need
Yeah.
to be aware of all those. Great. I'm just
Yeah.
gonna. I hope that answers Varun's question. I'm just gonna let it get back to your explanation. Thanks again. Okay, over
Thank
to
you.
you.
Yeah. So basically, Docker also has an orchestration engine, which is called as Docker Swarm. We can use that as well. But that also does not mean that Kubernetes is different, or Kubernetes, each of these orchestration engines like Apache, Mesos, Conductor is another uh, orchestration engine by Netflix, and they are also using, and I forgot its name, for the infrastructure as well. But anyways, all of these orchestration engines basically orchestrate these containers in the cloud when they are running. So they have nothing to do with the repositories or images. They only handle the running images. So to deploy your containers into the cloud or on these Kubernetes clusters, all you need is continuous integration and deployment. You can do it manually as well, but continuous integration and continuous delivery or deployments are important, very important part when you are developing a software application. Because, uh, for example, Netflix deploys a new feature or anything every 10 seconds on their cloud. So just imagine they have hundreds of thousands of microservices running on cloud, and if they want to run a particular or deploy a particular microservice, what would they have to do? They have to first of all kill all those previously running microservices, then deploy their new feature. And each of these deployments will take time, and manually they will have to see that everything is integrated properly. They will have to test it well, and then everything goes live. But manually, I cannot even explain that how would they do manually, because it's hard to imagine it. So continuous integration and continuous delivery basically brings in the concept that the software developers or or the developers of the application are different from the operations. If they are different from the operations or the network operations, then what happens is the concern is different. When they develop, they don't know what is the infrastructure. When they deploy a commit, they don't know what is the infrastructure, whether it's a Docker Swarm or Kubernetes, or is it running on AWS, GKE, or even on Azure. They don't know. They just commit on their builds. All that deployment will be handled by the continuous integration and delivery scripts or platform, and it will be well tested for security, for user acceptance and everything else. And then it will be monitored by the DevOps, and a response will be given back to the developers that okay, your microservice X has uh, this performance issue, for example. So improve your code or do this or do that. So continuous delivery is very important. Okay. So for implementing continuous integration and continuous delivery, there are many different tools like Jenkins and like GitLab, or even now GitHub has started the GitHub Actions, and many other platforms like Circle CI, and all of these. What they do is they provide you with the infrastructure to handle those this particular continuous integration and delivery pipelines. But what GitLab gives you is, apart from the continuous integration and continuous delivery, it gives you the option to manage your code, to plan your builds, to plan your project or issues, and then create your code on cloud as well, then verify it by using different tools, then package it into GitLab provided Docker repositories, because as I said that there are many different Docker registries provided by Google, Docker Hub, and even GitLab. So GitLab provides you a personalized or a secure Docker registry on cloud as well. So this is where you can package it. You can secure that as well, just because it's your personalized, and you only have the access to it. And then you can manage your releases as well on GitLab. And there are ample number of different features that you can utilize on GitLab. So I'll be going through some of these features while giving you the demo. So I will start with the demo part because there's too much talking already. Let me see what is the time right now. Okay, we have a lot of time. Okay, so I will start with the demo part because we have very less time. So this is where my GitHub repository or GitLab repository, and the running application will be on this bitly. So I'll keep it here for some time so that you guys can note it. And let me just jump into the code. Okay. So I have prepared this application. It's a very basic sample application which has a server and a client side. So this is where my server lives, and this is where my client is. It's a simple Angular client written in Angular JS, and it's a simple Node server. And it does nothing. It has some basic feature of sockets and everything else. But we will not deep dive into the code itself because I'll not be discussing about the code here. Okay, so what I want is I want to containerize this application and deploy it on cloud, and by using GitLab. So all I need is a GitLab account first of all. So you can go there and you can open an account. It's free and you can use it, and you can have my repository. It's public. This is the URL. You can have this repository. I don't know how to make it large, but I have, it's the same repository here. You can clone it on GitLab. Once you clone it, what will happen is that it will start building. Why? Because I will just use my GitLab instance. Okay. And let me create a new project. So this is what you will be doing. Okay. Demo time. Okay. So when you create a project, it will give you some commands to basically create your repository from your local machine. So what I'm going to do is, on my local machine, the same project that I have, I will deploy on this particular repository, and then from here onwards, I will set up my CI/CD. Okay, let me just increase the font size here as well. I hope it's fine. Okay, so to do that, I will go here and I will open up. Okay, so I want to change my remote. First of all, this is wrong. First of all, I will see what is my remote for this repository. So git remote /v. So currently I have these remotes. So first of all, I want to git remote rename origin. So I'm changing my origin, previous project name, and changing into old underscore origin 2. Okay. Okay. So this is it. I have done it. Now I'm connecting my project to my new node, new remote. So if you can see, I have this new remote. That means my this project is connected right now. So all I want is push my changes. So to push my changes, all of these instructions are already written over here, but I think I have made all the comments. I just need to git push origin master. Once I do that, it will be pushed on my this particular project repository. Okay, to run this particular project onto the cluster, all I need is a cluster first. So let's go to the operations part of this particular project that I have selected and go into the Kubernetes page. So I will have to create a Kubernetes cluster for this project using Google Cloud provided or Google managed Kubernetes engine. I will use my company's email address. Okay, the account that you will be using has to have a billing enabled on Google Cloud. Okay, if it doesn't have, then then it will be refused in the next step. So I will show you how it will be shown. So let's see, assembly demo cluster. Okay, this is where your projects are, which are coming from the Google Cloud or Google Kubernetes engine. So I will be opening my Google Cloud Platform, GCP, just to show you what projects I have and what exactly I can do with this. Okay, not this. I need this. Okay. So this is where I can select my projects. There are different projects that I have on my cloud, and I can. Okay. So here it is. So billing is enabled. You can see over here. The billing is enabled. If the billing is not enabled, you will not be able to run any cluster on this project. Okay, let's go to the Kubernetes engine part in the left hand side and see we have any clusters running already. Okay, so we have this GitLab video cluster already running, but we will not be using this cluster. We will be using another cluster. So let's get back to the cluster part. So we will select this particular project, which has the billing enabled already. Once we do that, it will ask us about the zone and number of nodes that we want to use, that we want to run in this cluster. So Kubernetes is made up of nodes and master. So master basically is provided by the Google GKE already, the Google Kubernetes engine already, and it's free of cost. All you need to pay is pay for the nodes that you want to run. So nodes are the instances, or you would say the running machines on Google Cloud. So if you see this particular cluster, I have a cluster size of 2. So there are 2 nodes running and a total of 4 CPUs I'm getting from this cluster. So that means each of these nodes are running 2 CPUs and a total of 15 GB of memory. That means 7.5 GB each is providing me. So let's get into it. I will be using only, let's say, 2. And we have to check this. If you don't check this, then you will have to create namespaces and service accounts to connect. And that's a very advanced thing. I can talk about it later. And this option also enables Anthos, which is a new infrastructure or a new uh, cloud platform that is provided by Google to run containers. But maybe some other day we can talk about Anthos as well. So if we create the cluster, it will take some time and quite a lot of time, probably 4 or 5 minutes to run that cluster. So when we refresh it here, you will see that, I hope you will see that there is another cluster creating on the cloud. Yeah. So you can see that this cluster is getting up in some time. So once that is done, I will be showing you what exactly will happen. But it will take some time. I don't think that we will be having enough time. So what we can do is, whenever you will open a project on GitHub, I will just show you here that particular project. to set up CI/CD, you would need a GitLab CI.yaml file. This is where you will tell GitLab to run your cloud builds or deploy on the Kubernetes cluster. So this is the core of the file that you would be needing. There will be a Docker files, similar Docker file that I have shown you. For any project, you would need that Docker file to containerize, to make it microservices. So I will go through the Docker file first. So what this Docker file is doing is basically it's packaging my application using Node image from the Docker Hub. And it is installing all the network npm dependencies. Then it's copying the code, and then it is running the build. Once the build is done, then it will copy that build into a runner, which is another Node server, and then we are running that using the Node command once again. So this is all that this particular application is doing, and that's all we need to do to containerize my application. Now to run that on cloud, we need this GitLab CI YAML. Now this particular CI YAML, I will tell you, you don't get overwhelmed by this, all of this information. I will tell you each one of these information, where I have copied it from or how it is running my code. So basically, GitLab provides an auto CI option or auto deploy option when you set up a new project. That auto deploy option basically um, gives you the ability to create a new file like this. So all you need to do is create a new file in your repository, and you will be able to select a GitLab CI YAML from here and then apply a template. This is where you will choose auto DevOps. So in my other project, which is a new project, since I have Git cloned already, so we will not be able to do that, because when I have Git cloned or pushed the changes from my local repository, I push the GitLab CI as well. If I haven't done it yet, then I will be able to get this option to create another GitLab CI file. Once we get this information, once we get this CI file, we just choose Auto DevOps, and it will bring me here with all the scripts and all. So we copy this from here, take it to our code, and see what exactly it can do. So I will just paste it here, and I will show you from here. All it is doing is taking an image of Alpine lattice, that is a Linux image, and then it is creating some variables. So basically, GitLab has a service called uh, build runner. So build runner will basically run using this image, using these variables, and running these scripts, or the running these stages. These stages are basically the pipelines in your CI/CD. So it will basically build, test, deploy, review, and it does all the staging, canary deployments, and everything that you might think of for an enterprise application to do on cloud builds. But for my scenario, I have just a basic deployment. So I have kept the same stages, but I have utilized only two stages, the build and the deploy. So let me show you. If you don't do that, you have all these stages, and there is a template that you are bringing in from the GitLab repository, which is here, and you're just mentioning that you copied this configuration from here. So GitLab has provided some pre-configured build configurations or test configuration or code quality configurations by default for all the microservices based applications. So you don't need to do much. However, I have written many GitLab CIs, custom based GitLab CIs as well. But for most of the cases, you don't need that. So let's say I don't need test, I don't need code quality, and I don't need all of this. I just want to build and deploy. So I will be using these only. Yeah.
I'm just coming on screen. Arsalan, quick question for you. I mean, like you just
Okay.
mentioned that there's a lot of this stuff that you can just you can keep the code on. It's fine.
Okay.
I just wanted
Mhm.
to ask you regarding that. So this is really interesting. I mean, a lot of stuff, and this is pretty impressive from GitLab in particular. I mean, they seem to
Mhm.
have put a lot of this facility. How easy is it to build, like, say, maybe a pipeline like this, and then take any app, say supposing I create a new Node.js app, and then just take that and
Mhm.
just replace it into the same
Mhm.
settings? Are these all like saved as settings files? And you mentioned you have the YAML and different things. So is it possible to just suddenly like take any existing Node.js web server and just like how long would it take maybe
Convert.
to just
Yeah,
convert?
you're right. You're right. Basically, you can do if it is Node.js server, Python application, or anything of that sort. Basically, all you need is a Docker file. If you have a Docker file and you have containerized it already, then GitLab would know that this is a microservice, and it will understand that using this Docker file, it has to build your microservice.
Okay.
So this is where you are telling your GitLab CI/CD as well by utilizing this Docker file. You can create a Docker container, same like I have created earlier, and run it on your own machine as well. Run it
Okay.
anywhere. So basically, what you are doing is you are telling the CI/CD that this is my container and just run it, just build it or run it. So GitLab, what it does is it has all the code that you have written for your microservice. It has all your code already on the repository that you have uploaded. I have just pushed my code on GitLab. So it has all the code. It will run the Docker, and Docker will basically run the builds.
Do
So
you
I
use
will be
the
showing you the builds and everything in the pipeline running
okay?
once we will have that cluster up and running.
Do you use the
But my,
testing
my point
features a
is
lot?
that
Yeah.
these custom pre-built scripts would help you 95% of the time. 5% of the
Templates
time,
also
when
are
your
there.
application gets very complex or it has a lot of things to do, then you might need to write a lot of other scripts as well. Or you might have to customize the scripts. So you can go on this particular URL and you can download the script and you can do that. That's an advanced thing to do, but I have done it in some other project like these. uh, I will just show you if you have to write it for yourself and what exactly you will be writing. So basically, I have written it the same way, but what I have done is, if you see here, I have written many different stages myself.
Hmm.
Okay, instead of here, where it is very simple, just include these
Yeah.
script files, and that's it.
So it's all
If you
templatized
see
from the
this,
GitLab
yeah,
side.
this is all that I have to do.
Nice. What about the testing
Okay.
feature? Do you actually get in practice? Do you use any of the advanced testing before you deploy? Like because obviously, if you're auto deploying, you want to have some checks. But what sort
Yeah.
of tests do you do?
GitLab basically provides that. So if you
Very good.
see here, GitLab does the testing as well.
Okay, great.
But for testing, also again, you need to put the scripts in your code as well. Because GitLab will see that what test, like I have this karma.conf.
Uh
So
huh.
GitLab would know that it has to run the karma configurations, and the configurations are written here. So it will
Great. Yeah.
understand that okay, based on these configurations, run the test. So it will run the test. It will not only just run the test, it will also do browser performance testing for you. It
Nice.
will also do the container scanning for any security issues. So if you see, these are all the security tests that it will perform. It will see for any license management. All of these
Nice.
features will be provided in the GitLab enterprise account, but most of it will be provided to you based on the scripts that you provide in your code. So it will automatically run those scripts.
It's great
And
that they
the
provide
main
all
part
this.
is
Yeah.
that it will do the code quality testing as well.
Nice.
So when you are running the Docker file, it knows that it's a node application because you are using a from node.
Hmm.
So it will understand that it's a node based or a JavaScript application. So it will start running the code quality test as well. It will detect the files based on their extensions like d.ts, so TypeScript. If it's JS, it's JavaScript. JSX, it's React.
Mm.
Or PY, it's Python. Or something of Java is like for Java or Spring Boot or something of that sort. So based on the file extensions and different other settings, it will automatically detect and start running the code quality test.
Oh, this is great.
So
It's a
all of
very
this you can do
sophisticated thing.
without changing anything in these most of the times. 95% of the times you don't need to change.
No, wonderful.
Okay.
Okay,
So
I'll.
what I have done is just to simplify my deployment, I have just written only build and deploy.
Hmm.
So basically you can choose between what you want to do. You can do by just using the templates of your choice, or you can include here a variable like don't run review if you don't want to the review to be running. So
Hmm.
you can just because review is a stage, so you can just tell the GitLab not to run X, Y,
Wow.
Z stages by doing that. So if you copy that information, it's written over here. So so this is where you want to disable. So if you want to disable test, you just write test disable. Code quality, you don't want to run, code quality disable.
Wow.
So all you
So
need to do
just
is, if you want to
flags.
do it, yeah,
Now, this is amazing. I mean,
keep it
that's what,
like,
like, I think GitHub has a bit of catching up to
yeah,
do with GitLab on this, because this is, I had no idea there were it was so sophisticated.
yeah.
Anyways, I will
So
let you get back to your example. Thanks for the answer.
yeah,
Okay.
no problem. So this is how you can disable the code quality as well, or you can do whatever you want. So in your variables, you need to do this. Anyways, so let's get back to the simplest example of all time that I have. So I have not changed anything. I just removed the extra templates and remove all the comments so that you can see that it's a very small file telling GitLab to run my Docker file. That's it. So let's see what will gonna happen when we do this. Okay. By if GitLab will find a GitLab CI file in its repository, it will start running the pipelines. So if you see, based on my code, the pipeline has run and it has passed some stages as well. It has passed the build stage, but there are no other stages. This would be possible because the cluster was not connected. That's why it just ran the build stage. Okay, now since our cluster is connected, let us see. Okay, so our assembly demo cluster has been connected to our project. Okay, so we need to do some further installations of different applications on our cluster to basically do the deployments. So what we can do is, when you go into the cluster, it will give you the details and everything. It will ask you for a base domain. You can have your domain of your application, for example, fixonclick.com. So you can have this over here and then save it. And after that, I need some applications available on GitLab cluster or my Google Kubernetes cluster so that I can start deploying my application. So Helm Tyler is basically a package manager for Kubernetes. So we want to install this first because then it will help us install all the rest of the applications that we need. Okay, so once Helm Tyler is installed on our cluster, we can just install Ingress, Cert Manager, Prometheus, and GitLab Runner. So I'll be telling you about each one of them. Ingress is something that will help because the cluster is very secured on Google Kubernetes. We cannot access the cluster. It does not provide any IP address or something of that sort to access the applications which are running inside until and unless we have a service or a service discovery built inside our cluster. So this is where we need Ingress. So we are installing this Ingress. This Ingress will provide us with an IP address to access the cluster which is inside. So from outer world to get inside the cluster, we need an ingress. And you can modify the application firewall. It's the latest feature that GitLab has introduced over here because previously it was not there.
For 1 second.
Yeah,
Sorry, just one more question which we got from Josefa Salim. He's asking,
yeah.
does two nodes mean one worker and one master node?
No, master has been provided by Google Kubernetes already.
Okay,
That's free of cost. You are just adding the nodes, the
you're
worker
just adding
nodes.
the
That's it.
nodes. Okay, okay, Josefa. I hope that answers your question. I'll put it
Yeah,
back.
most of the cloud Kubernetes providers provide the master for free. So this is where we got the IP address. So we can copy
Okay,
this IP address because this is where we will be connecting our uh, cluster from inside.
okay. I'm just gonna
Okay.
leave
So
it with you. I hope that answered Josefa's question.
yeah.
Okay, thank you.
Okay. Now let's get back to base domain. So if you see, once we have installed the ingress on our cluster, we have been provided by a domain which is our base domain. We can utilize this base domain as well if we don't have a wildcard domain on fixonclick.com. That's an explanation for some other training that what's a wildcard domain. But my point is, if you don't have a fixonclick.com and you just want to test your application, all you need to do is copy this domain, which is provided by nip.io, and then save it. This will create a base domain for your cluster. Now, once the base domain is created, we will look into the further installations. We have installed a cert manager as well. So cert manager will automatically install the SSL certificates. I have seen many companies struggling with their SSL certificates and managing their SSL certificates. Last night itself, there was a problem with one of my friend who was working for a company where he was having the issue of installing the cert certificates, SSL certificates for a particular website, and the client has provided him for the .com, whereas he required for an org or vice versa. So there are a lot of issues. You just think of microservices and the websites or the domains that are running, and you want to basically manage all those certificates. It's completely complex. But this particular cert manager will help you create the certificates on the fly. You don't need to do anything. Just provide your email address so that it keeps you posted with all the certificates when they are getting renewed and all that, and that's it. And you don't need to install it manually on your Kubernetes cluster. All you need to do is press the install button. It will be installed, and the domain that you have provided here, it will, whenever you will do a deployment, it will ask for a new SSL certificate, or whenever there is a new domain created for this particular domain, because there will be some dynamic domains like review or like staging. So these domains will be created by the cluster because of our CI/CD to test, to do the quality assurance, and many other things. So all of these for different environments, it will create different domains. So for each of these domains, this cert manager will apply for a SSL certificate automatically and install it on the cluster. Then comes the Prometheus. So Prometheus is a monitoring engine. It will also be installed on our uh, Kubernetes cluster to basically monitor the applications that are running on the cluster itself and the health of the cluster itself as well. Then the GitLab runner. So this is what I was talking about when I was talking about the runner for running the CI/CD pipeline. So the GitLab runner runs your CI/CD jobs. So this is your processing microservice. So it will take your CI/CD file, reads it, and then find the code on your repository and build it or do whatever you inform it to do in your CI/CD file. So it is required if you want to run your own runner, which is highly recommended. So how you can configure it, that which runner runs my code or my CI/CD pipeline, you go to the setting, go to the CI/CD part, and look for runners. So GitLab provides some shared runners already. You can disable them and you can use your own runners, or you can utilize the shared runners. But GitLab provides certain number of hours, like here 2000 CI minutes per month are free for you. So if you are running your builds, a lot of builds, 2000 minutes are free if you are using the shared runners. But after that, you need to pay. So GitLab has different plans. But what you can do is you can disable them altogether, and you can just use your runners which are installed in your Kubernetes clusters. So you can see I have two clusters. Each one of them has um, two runners. I can enable the other cluster based runner as well here, just in case if I want to run parallel builds or parallel processing on my GitLab runner, I can utilize this as well. However, a runner running on Kubernetes engine is already basically, if you have parallel loads, since it's Kubernetes, and while I was telling you here in my presentation that Kubernetes does the auto scaling automatically. So what it will do is, when we will run our parallel load on this single runner, it will create multiple instances of this runner on the cloud on Kubernetes engine as well. So you don't need to worry about that. And I will show you that over here. Okay, so let's see. Our operations are all done. Okay, let's run a pipeline. Let's see, what do we have? Mhm. Okay, so now since I have uh, created my, okay, there is some setting that we need to do, but I will just finish from here. Now, since I have created my cluster, I have configured my ingress for the cluster. The GitLab has automatically detected that the cluster is already connected, the runner is already configured, so it has given me the production pipeline as well. So right now it is running the build stage of my pipeline. Let's get into that. Okay, so if you see here, what it is doing is it's running a GitLab runner on this particular runner. So GSF is the ID. If we go here and see which one of the runners is this one, so we go here, we see here GSF. So you can see it's using this particular runner. And if you have enabled the shared runners, and if it is running any of these runners, you will understand. And sometimes you want a particular runner because you want a runner installed with a Docker, you want a runner installed with Microsoft services, .NET, or something of that sort, like shared Windows or Windows runner. So you can utilize these ones as well. So how you can utilize is by mentioning the tag in your CI/CD file, and you can say that I need shared Windows. So when you will mention this tag, GitLab will automatically select all those one of the runner which is free but having this particular tag. So this is all from the runners part. Now, after that, preparing in Kubernetes executor. Since we have connected Kubernetes, it has detected that it's a Kubernetes executor. By doing that, it will auto scale the runner whenever uh, additional load or a parallel processing is required or a parallel build is required. Then it is preparing the environment. Then it is getting the source from the Git repository. Remember, this runner is running in our cluster, which is on GKE, Google Kubernetes Engine, here. So within this cluster, this particular build is running. Okay, this runner is installed and it is running over there. So to access my code, the Git repository has to be cloned here on this particular cluster. You will not be able to see what exactly it is, but how it is running, because there's no display for it, but it will do the Git clone of my code. Once that is done, it has detected that there is a master branch which has a particular reference, and then it is checking out this particular SHA. Then it is skipping the GitLab's submodules because there's no submodule in my repository. And then it has started running the build process using the CI script. So this is the running before script, which is mentioned in my CI script. And then after that, once the before script is finished, then there are some build processes that it will run. So let me show you. So it is basically pulling from my previously deployed Docker image just to do caching, because if I have deployed already, it will only build the changes. So it will not build the complete project again and again. So by pulling this from the previous build, what previous build? If you see that when I deployed my code, it has already built all of my code already. Okay. So the first time when it was building, it never pulled because there was no image in the repository. I will show you somewhere here. See, it's a huge build that it has run for us. Wow. Anyways, so it was trying to pull. Okay, here. This is where it has started the building process because there is no response from, if you see error response from daemon, there was nothing here. There was nothing here. Okay, not found, manifest unknown. So since it was not able to find, so it has started from the stage one, step one, without pulling anything from the cache. However, in my new build, it has pulled from the cache. Once that is done, it will read my environments. If you see here, this is where first step already exists, already exists, already exists. So these three steps were already cached. So it saved some amount of time. I can implement my Docker file in a better way so that it will be more performant as well. But anyways, then it has gone through my Docker file, run the npm install. This is how the npm install finished. Then my Docker file said after doing the npm install, do the code copy, which is here, sixth step. Then I told the Docker file to run my build. So when it was running my build, you can see this is what happened in my application. It has ran production build. It has ran on the Angular project first. Then once that is finished, then it has ran a Webpack build for my server as well. So my application is made up of two, a client and a server. So both those builds were running. Once that is finished, it started removing the containers, then created another container only with the deployment code. And once everything is finished, it has pushed a Docker image onto this particular repository. So we will go there and see how it is. So when we go into the packages, you can see this container registry. So GitLab provides a free container registry up to 10 GB. You can store it over there. So you can see there was one image, and you can see that this is a particular SHA which was used for building the repository. And this is our latest tag. It has just built 2 minutes ago. So this is your container registry, which has your particular image, your application image. Now let's get back to the pipeline and see the production stage. So the production stage will utilize that registry and pull that prepared images and deploy it on the cloud. So it would be very small stage. It basically we have installed the Helm and all that. The production stage will only pull the image from here, demo time production, and run it in the cluster. Okay, so this is it. It has also ran a lot of other services on Kubernetes cluster. I will go through them very quickly but this is how it has prepared all the job, and the job is succeed. I have done nothing special in the custom CI/CD file. Okay, instead of that, I removed most of the code from this file. Okay, all I have done is written a Docker file. If you know how to write a nice Docker file, that's enough for you to know how to deploy on GitLab, because you can use the auto DevOps and you can use only these predefined builds. Once that is done, let's get back to our console and see. Okay, before I do this, I want to tell you that how to connect to Google Cloud. Okay, so since this is our cluster assembly demo, we need to connect our console with this particular cluster. All we can do is press this connect button, copy this command, and just paste it over here. By doing this, we will connect to our cluster on the cloud. So you can see that we have connected our kubectl client get all to our cluster. We will not be able to see anything much, but it's connected, and you can see that there is one service Kubernetes is run. But remember, when GitLab deploys on a cluster, what it does is it creates a namespace for that cluster, and that namespace we need to find by using kubectl get namespaces. So you can see that this particular demo time namespace is created. So we will say that kubectl get all dash and this particular namespace. Now we will get to know that what all is running in our namespace. So these are the different containers that are running. So these are the different pods. Now pods are the smallest executing, you could say, instance in the cloud in the Kubernetes cluster. And these are different services and these are different deployments. So the good thing about the deployment is that if I want to kill this, or somehow this particular pod is not working good, what I can do is I can tell it to restart the pod. So kubectl stop, sorry, container rm delete. I'm confused with Docker and kubectl. Delete pod and this production. Okay. Delete pod dash and this namespace. Production 6B. Okay. So I'm just removing by force this particular pod, okay, which is running my application. So when I do that, this deployment makes sure that I have a running instance of this particular pod at all times. So it will make sure and it will restart my pod automatically. Okay, so I have done it. Okay, git configs. I will just run this command because I cannot write the namespace name. Set config dash dash current um, namespace. Oops. Oh, this is not Git. See, live demos can be challenging sometimes. Okay. Okay. CIW cube CTL. Okay. Now if I do kubectl get all without mentioning the namespace. Okay. So I killed the previous one and it has started running again. Okay. How to show that? Kubectl describe pod production dash 6. Okay. So the container is running and all. You could see that this container is running. If I describe uh, deployment, it will tell me that what happened previously. Okay. You can see here the deployment has scaled up the replicas because kubectl get deployments. Okay, so this particular deployment we were looking at, it is showing that this deployment was scaled up a while ago. Okay, so that's all that we need to do. KGA. So that's all that is running on our namespace or for this particular project on the Kubernetes. Okay, let's test the URLs. To test the URLs or to see the live, all we need to do is go into the environments. We have only the production environment. Let's get into it. Okay, so these are the different builds. If you press on the view deployment, view live deployment, you can see there's something wrong with the SSL, but I hope that this SSL will be done after some time. No, this is some other deployment that I have opened. Okay. Okay. Okay, let's take it from here. Sorry, is demo time. Okay. So I have a old code. I haven't pulled it. Okay, but that build will take a lot of time. So anyways, I have prepared the project already that I have ran earlier. So this is that particular project and these are the pipelines. So one of my colleague has done some deployments early in the morning or probably late night. So I don't have these changes right now in my code. So I can pull them and then redeploy it as well. But anyhow, when we do that, after that, I have environments here. You go to your environments. If you deploy on a particular branch of GitHub or on a particular branch using Git, it will create a new environment under the name of that branch. So that's how the environments are. So you open live and our application is running. You can see that our SSL is also configured. Okay. So what this application is all about is just a basic application. It just creates a room. Let's say I create a room name Arsalan. So Arsalan, and if I press OK, it will connect me to that room. So you can connect to this particular room/Arsalan. The same bit.ly URL that I have given you over here. This particular bit.ly URL is running the same client. So if you run that, you will be connected in this room. So this is it. Nikhil, if we have more questions, please let me know.
Wow. So that was everything. That was great stuff. I'm just checking if we have more questions. No, everyone's just answered in. So Varun D is saying thank you. Looking forward to more virtual workshops.
Thank you.
And
Thank you very much, Nikhil.
and Atif Shahbaz says, nice work, Arslan. Mumtaz Kazmi said also, great explanation, Arslan. So lots of great
Thank you.
feedback coming in. This is, it's an eye opener for me also. I mean, of course, I'm also a developer and I've used Node.js, but I
Mhm.
never thought of doing that. But the ease with which you've shown that makes it,
Yeah.
very, there's
Yeah,
something
it's
very
it's
different.
super easy. People think that it's some very difficult stuff, but now the latest toolings like Circle CI even or GitLab Actions or GitHub Actions and GitLab CI/CD, they have built some amazing tools to help even the normal software developers to deploy on even Kubernetes clusters or OpenShift clusters or even on any AWS clusters or cloud managed Kubernetes clusters.
Wow, that's no, it's fantastic. I mean, I was just mentally keeping a note of all the tasks you were doing that you were able to automate,
Mhm.
and if you had to do those the long way, the
Yeah,
usual, say back, maybe even a few years ago, if you had to do all
yeah,
that.
it's completely complex. I was not showing you, but this is how it can get complex. The normal functions that you write, it can get very complex. The CI/CD
Yeah,
and even the deployment YAMLs and everything, it,
yeah, and
it, it can get
it's so much
completely
overhead
complex.
also that way you are managing all
Yeah.
these different
So
things.
that's how you write it custom. That's how you write it custom. You write a lot of code for your deployments. You write a lot of code for building and all that, and even on the CI/CD part. But you can do it on the easy way as well, which is I think the recommended way of doing it nowadays if your application is not very complex.
Now, what's great also is like because it's also modularized, I think you could, if potentially in a company, in a big organization, you could have the developers concentrating on their part of like building all these
Yeah,
modules, and the DevOps
yeah,
guy could handle all this with a little bit of code. And, of course, they'd need a little bit
yeah,
of where they'd access GitLab together, and there's
yeah,
something, but you could completely separate the functions and you could add on, and people could work side by side, and it would make you a lot more
yeah,
efficient. So this
yeah.
is a great tool.
So
Can
you
you
can see
also?
here that multiple team members, like I was building this application initially,
Hmm,
and later on, one of my team member has deployed or basically pushed the code. The push the code changes. So if you
nice,
see when I was showing you this one, this particular application is all till here where I have done this because after that my colleague has done some deployments and I haven't pulled it
hmm.
and before pulling I have pushed it to GitLab and tried to deploy it. So this is what happened.
That's great, and
So
you can
but
probably
once
get
I've
lots
done
of
it,
analytics also, I'm sure.
yeah, yeah. And the analytics part, you can just go to the operations and you go to the metrics. And this
Nice,
is where, because of installing the Prometheus, you will get a lot of complex analytics from your cluster as well as your microservice. So
nice.
you could see that
You
the
can see
memory
everything.
usage, the core usage, the memory usage by the pod. Because if you
Oh,
see, the pod was running, and later on I killed the pod.
there was a dip.
Once I
That's
killed
right.
it, it again started running. So the core usage and everything you can see
Hmm.
from the matrix part. This is just only we installed the Prometheus, and GitLab has integrated Prometheus dashboard onto the GitLab itself.
No, fantastic. No, that's a lot of great stuff. Arslan,
Yeah,
yeah, I will get the links from you also, and I'll share that on our
yeah,
description. And
yeah.
then people can definitely. You've also shared
Do,
your
do you
links in
think
this.
that you would need this presentation, or
We
I
can put
think
that up.
these links are enough. This is the public repository. You can pull from this particular repository, and to run the application, you can just
Yeah. And you can
run it
also
from
share
here.
the Medium article you did, because that was also very detailed, so
Yeah,
people
yeah,
can
yeah.
see
You,
the
you
previous
can
work
put that
also.
in the description.
Great.
Okay.
I will share all of that. Uh, yeah, no, I mean that's about it. I think, like, and we were good for time also. I was When you
Thank
said
you.
all that stuff was going to be done, I didn't think it would be possible in about an
Yeah,
hour. I mean, after the explanation. So that's
yeah.
a big, if we could, a big tick mark for how effective this medium is. Thank you again,
Yeah.
Arsalan, and appreciate
Thank
it.
you.
I know, like, you are your time is like very precious, because you you obviously are working on
Thank
these
you.
live situations, and like I said,
Thank
software
you.
these days is right at the forefront, so there's a
Yeah.
lot of
Now
figuring out.
nowadays people ask, how are the vacations going on? So most of the people, yeah, I'm sleeping, waking up and eating, and then sleeping again and again and again. But we are software developers, so our answer is that we are software developers.
Developers and
So
IT people are like, in general, systems
yeah,
people, I think, are working overtime now more than anything. I've seen, of course,
yeah,
there are lots of systems, there's a lot of load, so many people using things.
yeah, yeah,
You need a
yeah.
lot of
We
time.
have been using these mediums already, the Zoom and the Teamweaver and all the team meetings and everything. And we have been working remotely. The software developer has nothing new except the fear of the this current fear that everybody has.
Exactly. I mean,
Except
we're
that
used to.
software engineers are always the same. They have all these pressures, working from home, working from remote, giving presentations from remote, and everything is no different to for the software
Yeah,
engineers
it's
or
a
IT
it's a
professionals,
it's
I
a
would say.
new it's a new way of doing things, but for most people,
Yeah.
but we are used to it. You're right.
Hmm.
Thank you again, and we'll
No
definitely, like,
problem.
touch base with you again. I'm sure there'll be lots more questions, and people will be keen to see. So, thank you again for doing this. I remember, like, you've been a member. We met at Show and Tech, of course, last
Yeah,
year
and in five,
at
in five.
In5.
Yeah,
So, but
yeah. Hope
it's
to see you again. Hope to see you
hope
again.
to
I
catch
hope
up with you
that
again,
that
and once everything opens up, I hopefully we'll maybe get
yeah.
you back for a live
Cool,
session as well. Thank you
cool,
again, and
cool.
have a great day.
Thank you.
Okay.
You too, Nikhil. Thank you.
Okay,
Bye.
signing off, everyone, from both of us.